Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic Python code for simple linear regression algorithm. Regression analysis in machine learning. Regression analysis consists of a set of machine learning methods that allow us to predict a continuous output variable y based on the value of one or more independent variables. Regression analysis is the process of estimating the relationship between a dependent variable and independent variables. For example, regression predicts continuous or real values such as temperature, age, salary, price, etc. Simple linear regression is the most simple and popular technique for predicting a continuous variable. In simple linear regression, uh, one independent variable and one dependent variable will be present, and here the relation between the dependent and independent variable will be like this: y is equal to b naught plus b1 x. Here y is the dependent variable, x is the independent variable. Based on the values of x and y, a linear regression line will be plotted, and based on that particular prediction line, uh, the data can be predicted for the new values. Here b naught and b1 are the optimum coefficients obtained using LMS algorithm. Regression analysis will answer: is there a relationship between these variables? Is the relationship linear, and how strong is the relationship? How accurately we can estimate the relationship? How good is the model for prediction purposes? Regression methods. Linear regression methods. Simple linear regression, multiple linear regression, ridge regression, lasso regression, partial least square regression, principal component regression. Non-linear regression methods: polynomial regression, spline regression, etc. Regression equation. For simple linear regression, the equation is y is equal to b naught plus b1x. For multiple linear regression, the equation is y is equal to b naught plus b1 x1 plus b2 x2 up to so on up to bn xn. Polynomial regression: y is equal to b naught plus b1 x1 plus b2 x2 square plus up to so on bn x power n. Once again, I repeat, regression analysis is the process of estimating the relationship between a dependent variable and independent variables. Linear regression versus polynomial regression. For the given data, apply linear regression algorithm. If the scatter diagram is linear, then you can apply linear regression algorithm to predict the square value and optimum coefficients. Based on that, you can plot the regression line. Apply polynomial regression when the scatter diagram is not linear. Now in this case, the scatter diagram is not linear, so you can apply polynomial regression. Here, the polynomial regression degree is based on the number of independent variables. Regression equations. Simple linear regression. Simple linear regression is a regression model that estimates the relationship between one independent variable and one dependent variable using a straight line. You can observe for n number of iteration how the optimum values are b0 and b1 are calculated, and based on the optimum values of b0 and b1, the regression line will be drawn based on the equation just now I explained. Y is equal to b0 plus b1 x. The values of b0 and b1 x are calculated based on least mean square algorithm, LMS algorithm. Determine the optimum coefficients of a regression line using LMS algorithm. The optimum coefficients are b0 and b1. Now here uh, the predicted value of y is given by yi is equal to, let us consider here uh, uh, b naught is equal to beta naught and b1 is equal to beta 1. Yi is equal to b naught plus b1 xi plus some error, and here this particular error is the difference between actual y and predicted y. Now for n number of iterations, the error will be calculated, and the square of the error is given by the equation g of b naught b1 is equal to 1 by 2n summation I is from 1 to n ei square. Now here by applying LMS algorithm, you can determine the optimum values of b naught and b1. The values of b naught and b1 can be calculated as uh, b1 is equal to ssxy by ssxx, and b naught is equal to y cap predicted value minus uh, sorry, it is the mean of y minus beta 1, that is b1 multiplied by x bar. Now here the values of ssxy and ssxx can be calculated based on these two equations. Python code for simple linear regression algorithm. Uh, Import the supporting libraries NumPy and Matplotlib. Define the data. Here a estimate underscore coefficient. This particular function is defined to estimate the optimum coefficients of b naught and b1. Enp dot size will give the number of observations which are present in the data points. The next is uh, calculation of mean of x and y variables. The next is calculating cross deviation and deviation about x, that is uh, ssxy and ssxx based on the given relations, and from this equation you can determine the optimum values of b naught and b1. The function estimate underscore coefficient will return the values of B naught and B1. The program will be continued in next slide. Here one more function is defined to plot the regression line. PLT dot scatter of x comma y will plot the scatter diagram between the data points. Here, based on the predicted values of optimum predicted values of V0 and V1, we can determine the new testing value of y, that is y underscore predict is equal to B0 plus B1 x, and here a regression line is drawn between input x and predicted values of y. Uh, these two commands for x label and y label, plt dot plot to show the scatter diagram and plot of regression line. Here, by calling estimate underscore coefficient of x comma y, will return the values of b0 and b1 to the variable based on the given print function. You can print the values of optimum coefficients b0 and b1, and with the help of plot underscore regression underscore line, it is function. By calling this function, it will plot the scatter diagram and regression line based on the coefficients calculated. The output of the program will be like this. Here, the optimum calculated values of b0 and b1 are given, and these are the data points. Based on the data points, the optimum values of b0 and b1 are calculated, and based on these particular values, the regression line is drawn. Here, this is the regression line. Now here, this particular regression line is defined for x values ranging from x equal to 0, x equal to 2, 4, 6, 8. Now here I can determine what is the value of y at x equal to 5. Now here, by extending this particular straight line to the regression line, it will predict the value of y. It is the value of y at x equal to 5. In this fashion, you can predict the new values of y variables. Coefficient of correlation. The coefficient of correlation is given by R, and R is equal to summation of x minus x bar, y minus y bar. It is the covariance of x and y, and it is the variance of x, and it is the variance of y. Uh, here, x bar is the mean of x, y bar is the mean of y. Coefficient of determination, it is represented by R square. It gives how best the drawn regression line fits the scatter data. Once again, I repeat, R square tells how best, either it is strongly or weakly, the regression line connects or predicts the original data points. Now here, for R square is equal to 1, this particular regression line best fits the data point, and the data predicted for new value will be with maximum accuracy. You can observe one more graph with R square value 0.7. Here it is the actual value, it is the predicted value. This particular model predicts the new value with the accuracy of 70%, and R square with 0.9 and 0.3. Just go through. If the data is linear, then you can apply linear regression algorithm. The data is non-linear based on number of variables. You can apply polynomial regression algorithm with the given number of variables as its degree. Now, how to calculate R square value using sklearn library? For that, import numpy, import from sklearn.matrix, import R2 underscore score. Here from sklearn.matrix, you are supposed to use this particular function R2 underscore score. It is the predefined method. It is a predefined method which is already available in sklearn.matrix library. From that, you are supposed to import. The next is define data. You can directly use the function R2 underscore score of this particular R2 under R square value will be calculated between the data points x and y, and the R square value will be assigned to the variable R2. With the help of a simple print command, you can display the value of R square. Here, the value of R square is 0.88. One more example. Here you can observe the data points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. Now here, if a regression line is drawn, then all the data points will be on the regression line in such a way that here the value of R square is 1, means the regression line best fits the data points with 100% accuracy. Linear regression using inbuilt function. Here, uh, in the previous example, uh, we calculated the coefficients which are obtained from least mean square algorithm, and in this example we are going to write the Python code for regression algorithm using inbuilt function. For that, need to upload supporting libraries. Libraries to be imported are numpy, plotting library, matplotlib.pyplot as plt, pandas. If you are dealing with data frames or CSV files, pandas is mandatory. And this particular linear regression model is available in sklearn.linear underscore model library. So you need to import the linear regression from sklearn.model sklearn.linear underscore model. Here I'm going to write a Python code which is based on salary data. Salary data consists of experience and what is the salary of a person. Now it is independent variable x, dependent variable y. Here between the dependent variable and independent variables, the value of the optimum values of b0 and b1 are to be calculated. For that, we have to follow the procedure. With the help of data underscore set, here this is the variable onto which the data.csv file is loaded, and here we need to split the data into input data and output data. Here x is the input variable, y is the output variable. Based on ilog function, you can assign the values of the experience of a person to variable x and his salary to variable y. That is here the syntax within the square bracket given is comma colon. Here colon means all all row data. First position implies row elements, all row elements, and followed by comma, followed by the column data. Here this particular column data implies from starting position to n minus 1th position, that is uh, uh, the values of data points will be assigned to the variable x except the last data point, which is dependent variable, and except dependent variable, the remaining data points will be assigned to the variable x. Here we have only one data point, which is experience of a person, that is except the output variable. Now here the salary data will be assigned to the variable, all the row elements are assigned, and colon comma 1 implies the salary data will be assigned to the variable y. Here for the given data we need to split the data into training set and testing set. That can be done with the help of the library and given syntax. For that you need to import train underscore test underscore split function, which is available in sklearn.model underscore selection. In this particular sklearn.model underscore selection, the train test and split library is available, and with the help of this particular library you can divide the data into train and test with the given syntax. This particular syntax is predefined, so you just practice x underscore train comma small x underscore test y underscore train y underscore test is equal to train underscore test underscore split x comma y comma test underscore size, means here the testing data is 30%, the training data is 70%, and by default you can select random underscore state is equal to 0, and here you can assign linear regression function to a variable called a regressor, or you can define whatever name you require. You can define with any of the variable as per your requirement. It is user defined, regressor is user defined variable. Now here after defining the variable you can utilize regressor dot fit x underscore train y underscore train, means here with the help of this particular fit function you can train the model. Once again I repeat, with the help of fit function you can train the model, and after training the value of y can be predicted based on the syntax y underscore predict is equal regressor dot predict of x underscore test. For the testing values, the y value can be predicted. Here the linear regression using inbuilt function, for that you have to follow the following steps: import library, import all suitable libraries, load data. You can load data with the help of pandas, or you can load the data sets which are available in cbal library also. Just go through the syntax and assign input and output variables, or divide the data into input data and output data. Here experience is the input, salary is the output. The next is divide the data into training and testing sets. Training and testing sets. Train the model with the help of fit function, and after that you can calculate, you can draw the regression line, and you can determine the R square values based on the syntax available in the standard inbuilt function libraries. Okay, let us continue to uh, the program. Continue to the previous program. Here pld dot scatter x underscore train, y underscore train, color green. Here this particular function will plot uh, the scatter diagram between the training data sets of x and y in green color, and plt dot plot x underscore test, y underscore predict, color red. In red color, a simple plot is drawn, that is a regression line which is drawn between the predicted values of y associated with x test, and the remaining are x title of the graph, x label, y label, plt dot scope, plt dot show will display the plot. The R square value will be assigned to the variable score, and you can display the value of R square. Now here the output plot is drawn. These are the data points, that is scatter diagram drawn between the training data of x and y variables, and it is the linear regression line drawn between the predicted value of y and training values of x. And for this particular regression line, the value of R square is 0.97, means uh, the model accuracy is around 97%. In this fashion, you can draw the regression line and determine the value of R square coefficient. Thank you. We will meet with the next lecture.